Good afternoon, friends. Today in chemical bonding, now I want to explain about the three concepts. One is dipole moment, bond angle, and Dragos rule. Dragos rules. First, I want to explain dipole moment. In dipole moment, generally we classify the molecules into how you define if a molecule polar or non-polar. This we will define by using the concept of dipole moment, that is denoted with mu. If mu is equal to q into d, this is the formula of dipole moment. This is q is charge of any atom. This is internuclear distance. This is internuclear distance. For example, if you take this is hydrogen fluoride, due to this electronegativity difference, the hydrogen is electronegativity difference is 2.1, fluorine is 4. Due to this electronegativity difference, partial delta plus charge positive charge, partial delta minus positive, because the electrons, bond pair electrons attract towards fluorine. Due to this, the partial delta minus positive charge, delta plus positive charge will be developed on the hydrogen fluoride molecule. This is charge. Charge is, if you take either delta plus or delta minus, any one, the distance between these two is considered as a, that is d. The dipole moment mu is equal to charge upon any atom into distance between these two atoms. If it is polar molecule, that is mu is not is equal to 0. If it is non-polar molecule, mu is equal to 0. If it is polar, mu does not is equal to 0. Non-polar, if you can define as a mu is equal to 0. Based on these concepts, we can easily find out if the molecule is polar or non-polar by using different types. We can identify. For example, if you take atomic molecule, different types. If you take monoatomic molecule, for example, if you take monoatomic molecule, take hydrogen, fluorine, chlorine, bromine. Monoatomic molecules, in this also different types. This is monoatomic homotype, means same molecule. If it is different, it is heteroatoms, means two atoms must be difference. In this case, because due to this there is no electronegativity difference between these two atoms similar, that's why this is mu is equal to, what will happen, 0, means these are non-polar molecules. This we consider as a non-polar molecules. In case of, if you take heteroatoms, for example, if you take HF, HCl, HBr, HI, these are the some of the molecule heteroatoms. Due to this electronegativity difference, this form partial positive delta positive charge minus delta minus negative charge, delta positive charge, delta minus negative charge, delta positive charge plus delta minus, like this. But in this case also we will consider which is highest dipole moment. Which molecule? HF, HCl, HBr, HI. If you take 1, 2, 3, 4, which one is having highest delta dipole moment? If you consider, for example, in this case, if your charge is considered, this is more. If your Q is considered, 1 is greater than, 2 is greater than, 3 is greater than 4. If distance is internuclear distance, if you take distance is greater than, due to the bigger size, from left to right, the size increases, automatically distance will be increased. If you take distance factor, 4 will higher, 3, 2, 1. But general concept we remember here, first of all we have to consider the charge. First we have to consider the charge. That's why this is the HF is having highest. This is the sequence of these dipole moments of the 4 molecules. This we have to remember. Not monoatomic, this is diatomic. Diatomic different type, 2, 3. Small correction. Next, if you take AB2 type, for example, AB2 type, that is AB type. First we have taken AB type, the diatomic. This is triatomic molecule. For example, if you take carbon dioxide, what is this? This is polar or non-polar? If you take this is structure like this. From this carbon, this is more electronegative towards this side. This is oxygen is more electronegative, delta minus, this is delta plus. This is towards opposite to each other, cancel each other. That's why mu is equal to 0. This is non-polar molecule. This is the AB2 type of molecule. In this case also we can take different examples. Next, AB3 type. AB3 type molecule, if you take consider. For example, if you take BF3, Bi3, BCl3, boron trifluoride, boron BBr3 like that. If you take BF3, this is the structure. By combining of these two, this is planar molecule. Due to this planar, mu unit is equal to 0. Means it is non-polar. Generally we consider what is due to symmetry. If it is symmetry molecule, this is symmetry will be existed in. Generally what will happen? The electronegativity difference will be, this is delta minus, delta plus, delta minus, delta plus. But what will happen? This is having dipole moment, this is having dipole moment mu. If you consider overall, this is a symmetry will be existed. That's why this is mu unit is equal to 0. This is finally non-polar molecule. This is in this case, if AB3 type, any molecule exists symmetry and also surrounding atoms are same, then mu net is equal to 0, means that is non-polar molecule. This is the in 3 cases, BF3, it is chlorine, BBr3. In this symmetry will be existed, surrounding atoms will be same. That's why there is mu naught is equal to 0. This is the, in 3 cases, dipole moment is 0. This point you have to prove. If you take, for example, if any molecule lone pair will be existed, that is generally, okay, if you take polyatomic molecules, polyatomic, next time discuss different molecules, polyatomic, like that. What will happen if any molecule contains lone pair, it is polar in nature. It is polar in nature. Maximum. Only in 2-3 exceptions, that is, if symmetry is present, then only it will lose the, that is mu naught is equal to 0. But most of the cases, if any molecule contains lone pair of electrons, that is mu naught not is equal to 0. Mu naught not is equal to 0. This is point how to remember. If, for example, if you take oxygen, water molecule, this is, for example, if you take ammonia, in this case, mu naught, for example, if you take hydrogen, methane molecule, but here is mu naught is equal to 0, but in this, due to lone pair, mu naught not is equal to 0, mu naught not is equal to 0. Why? Because this is lone pairs will like this, but due to this one hydrogen, this existed like this, but in this case, but overall there is cancel opposite side, that is mu naught is equal to 0. In this case, it is not is equal to 0. If you take 2 exceptions are there, you have to remember. One is, if you take xenon difluoride, how you can find out the hybridization? Z is equal to 1/2 into number of valence electron. Valence electron in xenon is 2, 8. Number of monovalent atom is 2. 8 plus 2, 10. 10/2, total 5. 5 is, Z is equal to 5 means sp3d hybridization. Number of lone pairs is equal to, how you find out? Number of lone pairs is equal to Z minus surrounding atoms. Number of surrounding atoms. Z is 5, surrounding atoms is 2, total is 3. 3 lone pairs are exist. sp3d means, what is the structure? Trigonal bipyramidal, TBP. TBP is the structure. If you take, how you arrange the TBP structure? If you take this one, for example, if you take these are the 2 chlorines, this is the lone pairs. 3 lone pairs are exist. In this case, what happened? 3 lone pairs. This is the planar inside like this. All will be cancelled like this. This is quite opposite to each other. Cancel each other. Finally, mu naught is equal to 0. This is non-polar molecule. This is non-polar molecule. Why? Because mu naught is equal to 0. If lone pairs contains, also it is xenon difluoride is non-polar. This is one of the exception you have to remember. If you take in case of xenon tetrafluoride also, if you take xenon tetrafluoride, Z is equal to half into number of valence electrons of the central atom is 8 plus surrounding atoms 4, 8 plus 4, 12 by 2, total 6. 6 means, Z is equal to 6 means sp3d2 hybridization. If number of lone pairs is equal to Z is 6 minus number of surrounding atoms 4, total 2. 2 lone pairs are existence. What is the structure? sp3d2, that is octahedral. If it is sp3d2 structure is octahedral. How you write the octahedral? This is the octahedral structure. If you take here this one, if 4 fluorines we put here, next 2 lone pairs are opposite to each other, they will cancel. Two lone pairs opposite to each other, they are cancelled. This is called mu net is equal to 0. This is non-polar. Why? Because if lone pairs contains also, this is having non-polar nature. One is xenon difluoride, another one is xenon tetrafluoride. These points we have to remember. Next, in case of organic molecules, how to find out the dipole moment? If you take for example cis trans, for example C double bond C, methyl hydrogen, one of this one, C double bond C, CH3, hydrogen and hydrogen. If you take another molecule, then we have to find out this is two similar groups are same side, that is cis. Two similar groups are opposite side, that is considered as a trans. In case of here also, two similar groups are same side, that is cis. Two similar groups are opposite side, that is taken as a trans. Which will having the highest dipole moment. If you take in case of carbon, hydrogen, which is more electronegative, carbon, towards the carbon. If you take in this case, which will having the highest electronegative, this one. Towards this one. But in this case, what will happen? Towards the carbon. Here, towards the carbon. They are opposite to each other. In this case, what will happen? It will be cancelled. This is similar group opposite to each other. It is cancelled. Cancelled means mu net is equal to 0. 0 means this is non-polar. But here, these two are different. This group is a net dipole moment will be existed. That is mu net not is equal to 0 means this is having polar in nature. Means cis is greater than trans. Mu cis is greater than trans. But what will happen in this case? If it is towards here, chlorine is more electronegative like this. But here also carbon is more electronegative compared to hydrogen. Here also chlorine is more electronegative towards the left. But in this case what will happen? They are opposite to each other. Cancelled. Means mu net is equal to 0. Mu net not is equal to 0. Means cis having more dipole moment compared to trans. But always cis is more electronegative than compared to trans. No, not like that. Some changes will be there. We have to verify it. If you take, for example, two different atoms. If you take C double bond C, chlorine, methyl, hydrogen, and hydrogen, C double bond C, hydrogen, chlorine, hydrogen, methyl. In this case, this is cis, two similar groups are same side. This is trans, which will having highest dipole moment. In this case, what will happen? This is towards this side, towards this side, towards this side, towards this side. But here, carbon, hydrogen, carbon is more electronegative. Next, carbon is mono. This will be cancelled. But in this case, chlorine is more towards this side. But the difference between, in this case also, will be cancelled. Here, what will happen? Here, cis, this is trans. In this case, please identify. Methyl and chlorine, this will comes net dipole moment here. But here, methyl and hydrogen, the net dipole moment compared to this is very less, because they are cancel each other. This is more dipole moment compared to this will automatically cancel, but the net dipole moment will be trans will be more compared to cis. This point you have to remember. Next, if you take, for example, you take next. To take, for example, in this case, ortho, this group is ortho, this is para, this is meta, this is para, which will having the more dipole moment. If you take this one, this is mu1, this is mu2, this is mu1, this is mu2, this is mu1, this is mu2. Difference between this is 120 degrees, in this is 60 degrees, here it is 180 degrees, which will having the highest dipole moment. This you have to find out. What is the formula? Mu dipole moment, mu is equal to square root of mu1 square plus mu2 square plus q mu1 mu2 cos theta. Based upon the cos theta, you have to verify. Cos 60. What will happen? Cos 60. Cos 60 is 1 by 2. 1 by 2. 1 by 2. Mu1 is equal to mu2. Then what will happen? Q2 will be cancelled. 2 mu square plus 2 mu square. What will happen? 4 mu square means 2 mu. This will get. This is 2 mu. Mu 1 by 2. 1 by 2 1 by 2 will be cancelled. 4 mu means square root of 4 mu square means 2 mu. If is cos 120 is equal to minus 1 by 2. Minus 1 by 2 means mu. This will get mu. Cos 60 root 3 by 2. Not what will happen? Cos root 3 by 2. Root 3 by 2 means root. One by 2. Cos 60 is 1 by 2. 1 by 2. 2 will cancel. Mu square. All mu are equal 3 mu. Root 3 mu. Root 3 mu will happen. Here in this case minus 1 by 2 minus mu square. One of the mu square is cancelled. Only one mu. Mu is existed. Next third one is 120. This is 0. Which will having the highest dipole moment? ortho is greater than, meta is greater than para. This is the dipole moments of this one, A, B, C. This is taken as, this is taken as B, C. You understood or not? Clearly tell you. Cos 60 is 1 by 2, or root 1 by 2 plus 1 by 2. 1 by 2 means this is 1 by 2, 1 by 2 will be cancelled, mu square. 3 mu square means root 3 mu. Cos 120 is minus 1 by 2. If you put here minus 1 by 2, minus, you get minus here. 1 by 2, 1 by 2 will cancel. Minus mu square, 2 mu square. Only 1 mu square will be existed. Square root of mu square is mu. If you take cos 180, 0. If is cos, this is 180 degrees. Cos 180 degrees is totally 0. Cos 180, what will happen? Mu is equal to 0. That's generally we can this is chlorine this side, completely opposite to each other, means mu is equal to 0. A, B, C. This you have to remember. Very, very important. Next, these are the some of the bond angles of the, based on the bond angles have to, one of the exception is in this case also, methyl fluoride, methyl chloride, methyl bromide, methyl iodide. This is also important in the question. What is the highest dipole moment in this case? How will you find out dipole moment? Dipole moment in this case, how do you find out? Generally, starting also I told you, the dipole moment mu is equal to Q into D. Charge of any of the delta minus and delta plus of the atom into distance between the two internuclear distance between the atoms. That is considered as a dipole moment. But generally, if you take which one is greater, that is finalized on the majority charge you have to consider. More electronegativity difference in which compound, that will be the final. But experimentally they have done it. What will happen finally in this case? This is one of the expression. Second is greater than, first is greater than, third is greater than 4. This is small exception. In this case, fluorine we have to get more as per our explanation. But experimentally, the chlorine will be the highest compared to the methyl fluoride. This point you have to remember. Next, we take NH3 and NF3, which is having highest dipole moment. If I take nitrogen, write it. This is the hydrogen, this is the hydrogen, this is the hydrogen, this is lone pair. This is 1, this is 2. In case of NF3, this is the hydrogen, fluorine, fluorine, this is the lone pair. In case of nitrogen, nitrogen is more electronegative compared to towards fluorine. This is overall dipole moment is towards that side. Plus adding, but in this case fluorine will be attract towards itself, but this is cancel minus, but in this case addition, because that's why the dipole moment of NH3 is more compared to dipole moment of fluorine. This point you have to remember. Next, in dipole moment also calculate the percentage of ionic character and also the percentage of ionic character. How you calculate the percentage of ionic character? One of the application, percentage of the ionic character, that is observed dipole moment divided by theoretically calculated theoretical dipole moment into 100. Then we have to calculate the percentage of ionic character. For example, hydrogen fluoride, delta plus delta minus. In this case, how much is the ionic character? Poisson's rule, that is different. That is percentage of covalent character. In this case, percentage of ionic character. How you to find? But if you take, they given different molecules, then they ask the dipole moment. Generally, dipole moment I have given formula Q into D. Charge of the ion is 1.60 into 10 to the power of minus 19 coulombs. Charge in the case of 1.6 into 10 to the power of 19 coulombs. Distance we have to calculate generally angstroms. That is 10 to the power of minus 8 centimeter. 1 angstrom is equal to 10 to the power of minus 8. Generally calculated in angstroms. If you take the electron charge, if you take in consideration of ESU, 4.8 into the 10 to the power of minus 10 ESU units. This is charge is in coulombs, that you have to consider 4.8 into 10 to the power of minus 10 ESU units. Charge into distance. If it is, this value is divided by 10 to the power minus 18, that is 4.8 into 10 to the power minus 10 ESU into 10 power minus 8 centimeter. This is divided by 10 power minus 18. Then we get the value of dipole moment in dB units. This we have to remember. Then we get this charge into distance, that is 10 power minus 8 centimeter. This value Q into D by mu is equal to Q into D. This is divided by 10 power minus 18. We get the dipole moment units in dB units. This point you have to remember. If you find out the theoretical, they give the distance, they give the charge. Based on that, they give the observed value of the dipole moment. Then you have to enter these numericals in this formula. Then we get the percentage of ionic character. This is how. This is about the dipole moment. How to calculate the dipole moment in different molecules and also these. Next we have to find out the bond angles. Next we have to